Hello to all, welcome to the channel Money's Gate Tech Vision. In this lecture, I am going to present the system of linear equations, about the system of linear equations from the topic linear algebra in engineering mathematics. System of linear equations. Here I have represented the equations a11x1 plus a12x2 plus up to a1nxn equal to b1. This is the first linear equation. Second linear equation up to m number of equations are represented here. So this is a system of m linear equations in n unknowns. N unknowns are nothing but x1, x2 up to xn are the unknown variables for this system equations. Okay, and then where aij here a11 to amn, that is generally represented as aij, which is the coefficient of xj in ith equation. Okay, so for example, if a12 means this is the coefficient of x2 in first equation, so that is the representation, and then x1, x2 up to xn are the unknown variables. b1, b2 in the right hand side, b1, b2 up to bm are the constant terms for the system. And here, this linear equation, this linear non-homogeneous equations can be represented as ax equal to b, where a is the array of coefficients of unknowns. a11 to amn are the coefficients of unknown variables. So this is a is a matrix form of coefficients. Otherwise, it is called as coefficient matrix. And where X is the column matrix, which consists of variables, unknown variables x1, x2 up to n, up to xn, up to xn. That means n unknown variables. Group of n unknown variables can be represented in the matrix form as capital X. And then B. Capital B is a column matrix which consists of constant terms b1, b2 up to bm, m number of constant terms. So this is the matrix form of linear equations. And note, homogeneous linear equations. This is a non-homogeneous linear equations. Homogeneous linear equations is only one difference. There are no constant terms. In the place of constant terms, there will be 0. That can be represented as ax equal to 0. There will be no constant terms. That's the homogeneous linear equations, which can be represented as ax equal to 0. In the right hand side, 0 null matrix will be there. And next one is solution for the linear equations. So again, I have presented the linear equations. For the solution of the linear equations, we need to know about the matrix form. One is coefficient matrix, other one is augmented matrix. Coefficient matrix is nothing but the array of coefficients of unknown variables, which consists of a11, a12 up to a1n in the first row, a21 to a22 up to a2n in the second row, up to m number of rows are there, am1, am2 up to amn. So these are the coefficients of unknown variables, which can be represented in the matrix form, that is called as coefficient matrix. And the next one is augmented matrix. Augmented matrix is a combined form of coefficient matrix and constant terms. Here we know constant terms are b1, b2 up to bm. Okay, it is a combined form of coefficient matrix and constant terms. In the last column, constant terms can be represented. Constant terms can be combined. So that is nothing but an augmented matrix. So for the solution, we need to know about the augmented matrix. So let me discuss the steps for the solution of the linear equations. How to solve the linear equations? This is the first step. First, we have to form the coefficient matrix and augmented matrix from the given linear equations. Linear equations will be given. We have to form the coefficient matrix A and augmented matrix, which is the combined matrix of coefficient matrix and constant term matrix. So AB, which is indicated as AB. And then after the formation of coefficient matrix and augmented matrix, we need to find the rank of coefficient matrix, which is represented as R of A, and augmented matrix R of AB. We need to find the both ranks of coefficient matrix and augmented matrix. Then we need to compare the rank of coefficient matrix and augmented matrix. Check whether the R of A equal to R of A comma B. That means check whether the rank of coefficient matrix is equal to rank of augmented matrix. So there are two cases, no and yes. If rank of A is not equal to rank of A is not equal to rank of AB means, that is rank of coefficient matrix is not equal to rank of augmented matrix means, this is the condition. If rank of A is not equal to rank of AB means this system is inconsistent. Inconsistent means there is no solution. We cannot find the solution for the given system for the in this condition. If rank of A is not equal to rank of AB, system is inconsistent. There will be no solution. And in the other case, if yes, if rank of A is equal to rank of AB, if the rank of coefficient matrix is equal to rank of augmented matrix means, there are furtherly two cases. First case is if rank of A equal to rank of AB equal to n, because n means if the given linear equations is of nth order means R of A should be equal to n, R of AB should be equal to n. Take for example, if a third order matrix, if the three equations are given means third order matrix can be formed. So if we find rank of coefficient matrix and rank of augmented matrix is equal to 3 means, both are equal to 3 means the system is consistent and we can find the unique solution. Unique solution will be there. This is a determinant. This we can tell it as determinant. Other cases there for equal to condition itself, other cases there. Rank of coefficient matrix is equal to rank of augmented matrix, but it is less than n. But it is less than nth order equations means, if for example, if it is a third order means, if it is less than 3 means rank of A and rank of AB equal to 2 or 1. It may be 2 or 1, but it is equal only. It should be equal only. If both are equal and less than n means, if this condition is satisfied means the system is consistent, but it has infinite number of solutions. That is indicated as indeterminate. We can tell it as indeterminate. So these are the two cases for the S condition. So this is the steps for the solution of the linear equations. Next I will tell you, I will solve some examples, one example for each case, for consistent and unique solution and consistent in infinite solutions and inconsistent. Let me solve the problems. Testing consistency and solution. Example problem 1. Here I have taken three linear equations. First, what is the first step? Formation of coefficient matrix and augmented matrix. Let me form the coefficient matrix. So coefficient matrix is nothing but the coefficients of unknowns. So here x, y, z are unknowns. We need to find x value, y value and z value. Okay. So here coefficients are 1, 1, 1 in the first row, 1, 2, minus 2 in the second row, 2, 3, 1 in the third row. This is a 3 cross 3 matrix, coefficient matrix. And augmented matrix is combined matrix of coefficient matrix and last column vector will be 6 minus 3 11. That is right hand side constant term 6 minus 3 11. So last column should be 6 minus 3 11. Now we can use the elementary transformation method to find out the rank. Okay. If you want to find the rank itself means, if you want to test the consistency, only consistency means we can use determinant method itself. If we want to find the solution means we can use elementary transformation method, because using that elementary transformation method we can easily solve the problem and we can easily find the unknown variables x, y, z. So let me go for elementary transformation method itself. So see here, for the elementary transformation method, first we have to consider these three elements. Okay, these three elements, that is lower triangular elements 1, 2, 3. 1, 2, 3. We need to reduce this as 0. Okay, we need to reduce this element as 0 and this element as 0. So for this element, if you want to make this element as 0 means row 2 should be subtracted, row 2 minus row 1 we can consider. And here this element, if we should make this element as 0 means row 3 minus 2 or 1. So we can put the steps like that. Row 2 can be transformed to row 2 minus row 1 and row 3 can be transformed to row 3 minus 2 or 1. So it can be transformed as row 2, 1 minus 1 is 0. 2 minus 1 is 1. Minus 2 minus 1 is minus 3. And for row 3 minus 2 are 1. So 2 minus 1 into 2, that will be 0. 3 minus 1 into 2, that means 3 minus 2 is 1. 1 minus 2 minus 1. Okay, so we have reduced, and the same method should be followed for the augmented matrix. Row 2 minus row 1. So row 2 minus row 1. So for the coefficient matrix, same thing. And last one, in the last column, this element minus 3 minus 2 into 6. Sorry, minus 3 minus 6. That will become minus 9. And here 11 minus 2 into 6, 11 minus 12, that will become minus 1. Okay, same steps should be followed for the augmented matrix and coefficient matrix. And further we can reduce here. Further we can reduce row 3 minus row 2. Here 1, 1 are the same elements. So we can reduce. So we can transform the row 3 as row 3 minus row 2. So row 3 minus row 2 is, see the row 3, 0. Again 1 minus 1 is 0. Minus 1 minus of minus 3 is minus 1 plus 2. Sorry, minus 1 plus 3. That will become 2. So first three columns will be the same, like coefficient will be nothing but coefficient matrix only. And last term, for the last term, first two row elements are same, and the last element is minus 1 minus of minus 9. That will become 8. Okay. So here, see, consider with this itself we can stop and find out the rank of the coefficient matrix and augmented matrix. So here we cannot reduce, and here also we cannot reduce. So we can terminate here, and we find the rank of coefficient matrix as 3, because 3 principal diagonal elements are there. In the 3 rows elements are there. So we can conclude that rank of coefficient matrix as 3. And the rank of augmented matrix also we can conclude that as 3, because 3 rows are there. So rank of AB we can conclude that as 3. So here what is the condition if we compare rank of A and rank of AB? Rank of A and rank of AB, that is equal, and that is equal to 3. 3 is nothing but a nth order, because given is third order matrix only. 3 linear equations are there. So this is the first condition. System is consistent and it has unique solutions. Okay, so we have the solution for this system. We can find the solution for this system. We can find the solution for this system. How can we find the solution for this system? See the last row of the augmented matrix. Using the augmented matrix, using the reduced augmented matrix, we can find the solution. So here, see here, this is the x coefficient and this is the y coefficient and this is the z coefficient. So z coefficient is 2 and the constant term is 8. So we can write the equation as 2z equal to 8. And from the second row, we can write the equation as y minus 3z equal to minus 9. And from the first row, we can write the equation as x plus y plus z equal to 6. So from this equation, from this first equation, we can find the z variable. And from this equation, let me substitute. If we substitute z equal to 4 here means y minus 3 into 4, that will become 12 minus 12 minus 9 plus 12, that is equal to 3. And then if we substitute y and z value in this equation means this is 3, this is 4. So 3 plus 4, 7, 6 minus 7, x equal to, x will become minus 1. So we have found the solution x equal to minus 1, y equal to 3 and z equal to 4. It has unique solution, which are the values are minus 1, 3 and 4. Unknown variables values are minus 1, 3 and 4. The solution is x equal to minus 1, y equal to 3 and z equal to 4. So this is the example for consistent system and which has unique solutions. Let me go for another example. So this consists of 3 equations. And see here in the right hand side, constant terms are 0. This is a one type of linear homogeneous equations. This is a homogeneous equations. The methods are same only. So let me form the coefficient matrix and augmented matrix and find the solution. Coefficient matrix is nothing but the coefficients. group of coefficients 1, 2, 3, 2, 3, 4, 7, 13, 19. And then augmented matrix is the combined matrix of coefficients and constant terms. Here constant terms are nothing but zeros. Okay, so the last column should be zeros. Will be zeros. Let me find the rank of this using elementary transformation method itself. So let me make this element 0 and this element 0. So if you want to make this element as 0 means row 2 minus 2 into row 1. And this element as 0 means 7 minus 1 into 7. So row 3 minus 7 into row 1. Okay. 7 into row 1. So here this is 7. Wrongly typed. 7. Okay. And a equal to, here see here, 2 minus 2, 0. 3 minus 4, minus 1. 4 minus 6, minus 2. And here 7 minus 7, 0. 7 minus 1 into 7, 0. Minus 1 minus 7 into, 13 minus 7 into 2, 13 minus 14, minus 1. 19 minus 21 is minus 2. The same first three columns will be the coefficient matrix, and last column is nothing but 0, 0. And then next is just see the row 2 and row 3. The elements are same values. Elements are having same values. Minus 1, minus 2, minus 1, minus 2, 0. So we can subtract these two rows. Okay, row 3 minus row 2. So if we transform row 3 as row 3 minus row 2 means the last row will become 0. Minus 1 plus 1, that will become 0. Minus 2 plus 2, that will become 0. And here already in the last column, zeros are there. So this is nothing but a 0. Okay. So if we observe this matrix, we can find the rank of coefficient matrix and the rank of augmented matrix because only two row elements are there. Third row consists of 0 only. And here also third row consists of 0 only. So we can conclude that rank of coefficient matrix as 2 and rank of augmented matrix as 2. Rank of A equal to 2, rank of AB equal to 2. So this is the second case. Here rank of A is equal to rank of AB, which is equal to 2, which is less than n. So here 3 number of equations are there, less than 3. So this system is consistent only, but it has infinite number of solutions. Um, how it will be having infinite number of solutions, I will tell you that. From this equation, we can write that, from this augmented matrix, we can write that last row. From the last row, we can write that z of 0 equal to 0. And then from the second row, we can write that minus y minus 2z equal to 0. From the first row, x plus 2y plus z equal to 0. So let me make z as constant k. So if you put constant k in the second equation means minus 2 into k. So minus y minus 2 into k equal to 0. Therefore, y equal to minus 2k. And if we substitute z equal to k and y equal to minus 2k in this equation means we will get x as minus k. So x equal to minus k, y equal to minus 2k, z equal to k. Where k is the constant term, for any k value we have the values. For any k value from 0 itself we can find from 0 to infinity, from 1, 2, 3, 4 up to infinity we can find the solutions. So the system is consistent and it has infinite number of solutions. For any k value, system has solutions, infinite, or it can be called as indeterminate. This is the solution for these equations. And the last example is here two equations are there. From the equations itself, we can find whether it is consistent or inconsistent. Here two equations are there, but three variables are there. X, Y, Z are the three variables, but two equations are there. We cannot solve. Now itself we can tell it is inconsistent only. For reference, I will solve the problem through the elementary transformation method. So here I have represented the coefficient matrix 1, 2, 3, 3, 6, 9 and augmented matrix 1, 2, 3, constant terms are 4, 3. And now we can simplify the row 3 divided by 3. if you simplify in this row 3 divided by 3 means it will become 1, 2, 3 in the last row. And here also 1, 2, 3, 3 by 3 is 1. 1, 2, 3, 1. Here these two rows are same. So again we can reduce. Row 2 can be transformed to row 2 minus row 1. So here the row 2 elements will become 0. And here in the last element row 2 minus row 3. 1 minus 4, that will become minus 3. So here when considering this coefficient matrix, this rank of A equal to 1. But when considering this rank of AB, here two rows has the elements. In the last row has one element. So we cannot decide it is a 1. We can decide it is a 2. Rank of AB is 2. So here the condition is rank of A is not equal to rank of AB. The condition is rank of A is not equal to rank of AB. So the system is, we can conclude that system is inconsistent but it has no solutions. Okay, it has no solutions. We cannot solve the problem itself. So these are the three problems for testing consistency. We have three options. One is inconsistent, one is consistent and unique solutions, and consistent and infinite number of solutions. We have solved some example problems. In the next presentation, I will solve some gate problems based on this. This is the Manish Gate Tech Vision channel. This is a channel for engineering competitive examinations. Subscribe to my channel, share the video lectures, and view the channel. This is my mail ID dmoneylecture@gmail.com. Thank you very much for watching the video.